Okay, so this is going to be the demo for the project. So pulling up the file. So for this overall, the code of the car wash simulation, it was overall already handed to us mostly complete and operational. So it already took in command line parameters for certain aspects of the car wash. The main thing that I changed to it was kind of like added the functionality for the Poisson distribution in regards to the interval at which cars arrive. So to do that, what I did was I kind of had like a boolean, like Poisson, and I set that to either true or false in order to trigger the manipulation of the interval, the t dash interval, and I use a SymPy random library which had a Poisson function that would make like a random, like a Poisson distribution for the interval times. So looking down here, after the Poisson variable is defined, we have a if statement right here, which pretty much sets the number of times the simulation will run. So for the Poisson one, I set it to repeat 6 times. And then for the regular case, with the fixed arrival times, I just have that as the number of machines. And then we go into the for loop. So if the Poisson Boolean condition is met, then it will get the random arrival time each time the simulation is run. And then that value is going to be used as the t interval time. The rest just operates like normally. All the processes ran in the environment, and then later on the result will be captured in the pandas data frame. Going down further, so this is where the plotting of the graphs happen. So again, there's an if-else statement. So if the Poisson statement is false, then it would just proceed with the normal default plot for the matplotlib. However, if that's not the case, then it would do the plotting for the Poisson. And in here, the main difference is that it's just going to kind of like plot the different like simulations ran, but each time they have a different interval arrival time, and that plots the difference in color codes that for easier examination and make it easier to analyze the data. So to run, so currently it's set defaults for the Poisson distribution. So I'll just run like a normal car wash simulation. So that's with 3 machines, so it decrements as it goes. So we see the simulation of the car line for 3 cases of 3 different machines. Also, we can change the variable so that it only runs with 1 machine, so that to show the command line input works. So there, it only has 1 car wash machine. And then for the Poisson, if we want to use that, we just go in and change the boolean to condition to true, and that will trigger all the necessary steps in order to show the Poisson distribution. So over here, set it to true, and now if we run it, so for the Poisson distribution, I default the machines to 2 for each run, so it doesn't really matter what the command line input is, so just default it to 2 to keep the data consistent. And that's the Poisson one. So all these different lines represent different time intervals that the simulation was run at. So we see that basically the smaller time intervals that between car arrivals, then the longer the line usually becomes. And then the longer the time intervals, the smaller the car line becomes over time. And then that detail as to why that happens is stressed more so in the reports. Basically, the car wash has more time to process through that line to shorten it before the next car arrives if there's a long interval time. And if the interval time is too short, then the car wash line will keep on getting bigger and bigger faster than it's actually dwindled down by the car wash itself. But that's overall basically the simulation and showing that the program runs correctly.